Wow, what a tough act to follow now, right after Dan. But I hope you all enjoyed this talk as much as I did, just preparing this. And I'm super excited to be here. Traveled all the way from California here, just got here yesterday in the afternoon, and I'm super excited to share a little bit of the story of how we built the next generation of the If This Then That platform. So I'm Neto, no affiliation with the supermarket. I just learned about it. No affiliation, that's actually my name. I'm Neto Farah. I'm an engineering manager at Segment. I live in San Francisco, California, but that's not where I grew up. So I'm really surprised that I've been here 24 hours already, and I haven't heard a single joke about that day. So that's where I grew up. You guys must really love GraphQL. You must really like it, because I haven't heard any joke yet. And I told a lot of people I'm Brazilian. OK, so this is a story about IFTTT, or as we call it, IFT. It's, I don't know if you're all familiar with it, but IFT is a platform that allows you to connect two different services on the internet and just do really interesting stuff with them. So one example I could use here is that if I take a photo on Instagram with the hashtag GraphQLEU, then back it up to my Dropbox, or repost it to Facebook, repost it to Twitter, or anything. So if you're ever curious about the sort of little apps that you can build, check out ifttt.com. It's a really cool service. So a little bit of the context in here. So IFT has millions of users. And because it connects all of these different, it allows for all of these different permutations between different services. We also saw billions of calls every day. So we're constantly running all of those if-then statements, and those are making a ton of calls outside. And we had a website, an iOS app, and an Android app. The tech stack at the time, so this story is about maybe a year and a half, 2 years ago, when I still used to work there, and it was really close. Like, it was about the same time that GraphQL came out as an open source tool. So a little bit of the tech stack. It was a seasoned Rails 3 monolithic app. So really good code, really good test coverage, but also a little dated. So it had multiple APIs, and I guess this is a pattern that a lot of people see in their app. You start with API v1, you don't like it too much, you start to realize all the mistakes you made. You go to API v2, v3, you create a separate API for some integration that you want to do. And it became, over time, very challenging for us to deploy, to iterate, and to run tests, because that code base was just massive. Can you imagine like all of those integrations that IFT was doing all on the same code base, alongside with WebView for mobile apps and an entire front end? And just to make this a little bit more fun, back in the day, I was the only web developer kind of maintaining all the web features in that code base. And then one day, because it's a startup, because it's still like working on trying to figure out their business model and everything, we get this challenge now that, well, we're going to change a lot of stuff, and we're going to have to do it really quickly, and we're going to build an entirely new product. We're going to keep a few things of the core, but we're just going to build a ton of new features. We're going to change the design drastically, and you're going to have to make a lot of changes, and you have 9 months to do it. Good luck. So, yeah. We knew we needed to make some changes there. We knew iterating was costly. It would just take a lot of time to make changes. Even testing your things in development and reloading all of that much code every time you make a change was a little challenging. So we needed to do something. And there's some textbook solutions, and there's an entire other talk that I could give here, and that many other people have given about the majestic monoliths versus the microservice. That's like the first thing that comes to mind when you're working on a legacy code base, and especially with Rails code base, is that I just need to break away from the monolith. That's the number one thing a lot of people think. And just there's an entire discussion about the pros and cons of going with microservices versus just refactoring your monolith and making it very efficient. But I don't think that's a binary decision. There's pros and cons to each one of those. There's multiple trade-offs. But we had a very tight deadline and very limited resources The entire team building this new generation of IFT was me building the iOS API, the Android API, the web API, and the web client, another team of 2 Android engineers, and another team of 2 iOS engineers, and a designer. So as you can see, there's like a ton of stuff that needs to be done there. There's a ton of decisions that need to be made, and there's all of those trade-offs. So we had this idea that we could go with kind of a hybrid approach and use what's best about microservices and also use what's good about the monolith that we had. So we thought, what if we just build a very rich API and then just build specific clients for those APIs outside of that main code base? So maybe we'll build the front end completely separate from the back end. We'll just try and build newer services now that don't necessarily touch the monolith anymore. And then, OK, after you make that decision, then you have that question, how can we make our front end and back end apps communicate? What are the common patterns that people see in the industry to just try and break away from those, from legacy monolithic systems? So the first thing you think is like, should we do it through the database? If you say like, oh, OK, well, we'll just create a new client and like just connect directly to the database. That's like super simple to do. And that's the only GIF I have. But why are database-driven integrations so tempting? It's because it's easy. It's because it's simple. You can load as much data as you want. You can load exactly the data that you want to load. You can get some nice granularity. And also another thing that you get that's really good is that you get some of those asset guarantees from your SQL database. You don't have to worry about distributed transactions anymore. You don't have to worry about all of those extra challenges that come with services. But why are they challenging? Why are they not a very good idea? One problem with database-driven integrations is that you have to repeat your abstractions everywhere. So you no longer have that safe level of abstraction that you have your APIs. Now every client that connects to that database has to kind of re-implement all of those details. Rollbacks are incredibly hard or just non-existent. If you make a change to your database, that's a permanent change that you make because you're changing the structure in which the data is stored. So it's like very hard to go back. You don't have like that same concept of versions that you have with like APIs, and then it's just incredibly hard to keep everything backwards compatible. So how do you deploy changes to your services now? Do you run the migration first and then take everything down and then wait for the migration to finish and then update your services? So that becomes super hard. So what about APIs? What about just traditional APIs? That sounds like the right direction to go, since we can get all of those good things. And here's where I think this gets really interesting, because these days, and especially with Rails, especially in the Rails community, it's just so easy to create a new API. Creating APIs is just incredibly easy. In Node.js, all I need to do is pull up Express and create a new endpoint. In Rails, all I have to do is create a new controller. It's super cheap, super easy. Our communities are used to do that. But we built so many APIs and we built so many endpoints that we all kind of start running into the same problems. And I'm glad that Jonas and Sashko gave their talks this morning, because they mentioned a lot of the things that I was going to mention here, so I can focus a lot more now on the specific cases for my talk. But yeah, back to multiple use cases. So yeah, the database-driven integration kind of solves that, but the APIs don't solve them too well. You might have like too much granularity into your API endpoints. Sometimes you don't have that much granularity. You have to cater to all of these different clients, so you just kind of gave up and built even more endpoints, because that's the easiest way to cater a lot of use cases. You also get different access patterns. So you might be loading stuff from the web. You might be loading stuff from iOS, from Android, from like your internal systems. Each one of them are going to use your API in a slightly different way. So you either end up with like those Frankenstein APIs that do everything and then eventually become super slow, or you're just going to have to make a ton of requests. And there's a talk I really like that Phil Calzado gave about when SoundCloud was migrating to microservices and how one of their pages was making 38 HTTP calls just to render the track list for a playlist in SoundCloud. So you end up having a ton of those problems too. And then you go back to another problem that's ambiguity with like traditional APIs. There's not really that much of like, I mean, you don't necessarily know what an API does and things like that. And then how you solve that? You solve that with documentation and conventions. And I love to talk about conventions, especially when I'm overseas, because this is like the universal sign for OK, right? Anywhere you go, you just do this, and you say, oh, yeah, it's all OK, it's all good. I was setting up the microphone, and I just did this. Except, if you go to Brazil, this means an entirely different thing that could be very offensive. So for me, to this day, it's still hard for me to just say to do this, but I don't mean the Brazilian meaning for this. But if you're curious, just come ask me, and I can tell you what it means. So how can we solve a few of these challenges that we get with APIs? So I'm just going to speed through this part too, because a lot of people talked about them. So types are good. Types are a really nice idea. They're predictable. They're kind of self-documenting. They simplify the documentation that you do, and it's sort of contract between different components. We also want to have the ability to load just what we need, so we can cater to all those different cases. And we want to always get predictable results. So you kind of know where I'm going, right, with this talk and with all of these requirements. I want types, I want predictable results, I want composable queries. I want GraphQL. It combines all of those characteristics that we wanted from database-driven integration. It's giving me all of that flexibility, all of that composability that I could get from my database. And it also gives me the good stuff about regular traditional APIs that I want. I want to be able to version my things. I want to be able to be backwards compatible. I want to be able to have a different deploy cycle and release cycle. So this is where this gets interesting. That's why this is not as much of like a traditional GraphQL talk, because we had this idea. What if we built a GraphQL API that just lives on top of our monolith? So maybe we just try and expose our data model as much as we can as GraphQL, and we get the benefits of all of those things. And then GraphQL becomes our integration layer for all of those not-so-microservices that we wanted to build, and those new UI components that we wanted to build too. So this is kind of how the IFT architecture looks today, except that we're writing software, so that's kind of how it looks. So there's an API gateway that lives in the front, and it takes care of just like cross-cutting concerns, like authentication, logging, and things like that. And we also have all of those services in the back. And the turtle just symbolizes slow requests and like the network failures and things like that. But then we have all of those services, and we have our GraphQL API that lives on top of the monorail. So my service A could be the newsfeed for IFT. It could be the search. It could be any of those services that we started to build outside of the monolith. And every time they need data, they just reach into to the GraphQL API, and they get the data that they need. And the same thing with the UI clients. They go through the API gateway, they load the data that they want, and they just get all of those nice things from GraphQL. So how was it like to run GraphQL and Rails in production about 1.5 years ago? So it was very early in kind of like the open source GraphQL days. So I was super excited to build all of this, but it was also incredibly challenging because there wasn't that much like tooling available, and we're still trying to figure out a lot of those very basic problems. I still remember we got on a call with some people from Shopify, and we're all talking about like all of these challenges that we're having, and their team had almost exactly the same challenges I was having at the time. So this is really interesting. It kind of like most of those problems are solved by tools today. So what I want you to take from the talk is not necessarily the solution, but kind of the process of like figuring those things out. And I'm just excited to share like how fun it was to just learn all of those things. So the challenge number one was what we call N+1 queries. So this is a very common challenge with GraphQL APIs. Almost every GraphQL API that I worked with or that I checked out the source code or played around had problems with N+1 queries. And if you're not familiar with what N+1 queries are, I'm going to get to them in a minute, and you have a good understanding. But that's an incredibly common challenge in Rails code bases too. Usually, any code that you work with that makes it really easy to fetch data, you're kind of setting yourself up for those sort of challenges. And because the data that we query with GraphQL is so dynamic, you don't know up front what to eager load. or at least we didn't know. We didn't know at the time. So here's an example of a GraphQL schema on the left, on my right, your left, and then an active record schema to the right. So if you look at those, you see it's like a super simple example that I tried to come up with. That's like just a restaurant. A restaurant has some recipes, and a chef has all of those recipes. Recipes have ingredients, and those ingredients are sold by vendors. So if you look on the other side, it just kind of matches kind of our database model. If you're not familiar with Active Record, that's just the pattern that we usually use in Rails, and that just maps those models to the database. So OK, if we run this query here, we'll just run a GraphQL query, and we're going to load recipes with their title, and then we're going to load the ingredients with their name, and then we're going to load the vendors with their name. So the green parts there are just like the levels, like how much I'm nesting in my GraphQL query. This is kind of what you see if you're just doing like the regular GraphQL, Ruby, and Rails setup. I just realized it's really bad to read. That's too bad. But the first query there is loading all the recipes. And then you see that I kind of bolded the extra ones that you see. You load every ingredient for every recipe, and then you load every vendor for every ingredient. So if we take like if we just zoom in and look at one ingredient, you see that, OK, we load the first ingredient for the recipe, and then we load all the vendors for each one of those ingredients for that recipe. And these are what's called N+1 queries. So I load my one query. So you remember that I was loading recipes, and then I was loading the ingredients, and then I was loading the vendors. So basically what's going on here is that I do my one query to recipes, and then I load n ingredients after that. And then I load my one ingredient, and I load n vendors after that. So you can see how inefficient this sort of thing can be, because we're making a ton of these round trips accessing our database. And we're also, if you have 1 million ingredients or 1 million recipes, if you're building a website that's all about recipes, if you want to try and load a big list like this, you're just going to be making thousands of queries against your database. So how do people usually solve this problem? A very common solution for this is data loader. Unfortunately, it's a JavaScript-only tool, at least as far as I know. So we were a Ruby shop, so that wasn't really an option for us. But it was a big inspiration for how we were going to try and solve that problem. And if you're not familiar with data loader, I'll recommend that you check it out. It's a super cool tool. Basically what it does is it allows you to batch all of those resolves that you're trying to write for each one of those components, the fields of that query. And then there was another tool that was coming out at the same time. So Shopify was also trying to solve some of the problems we were trying to solve. So they came up with this tool called GraphQL Batch. And it's super similar to how data loader works, and it lets you use those promises and everything. But you have to keep in mind that this was the early days of open source GraphQL. So there wasn't much documentation. And I felt like it introduced a little bit of complexity, and I didn't really have that much time to reverse engineer the code because there wasn't that much documentation there. So I just decided to put the problem in the back burner because YOLO, and deal with the problem later. But let's take a second look at our data models. So if we look here again, we got that schema again. We got the active record models on the other side. And I don't know if you can tell, but they're kind of one-to-one. They kind of map one-to-one. They're kind of like mirroring one another. I'm not suggesting that is what you should do with your GraphQL API. But most often than not, that kind of becomes the case. So keep that in mind. And then if you're familiar with Ruby and Active Record, you probably came across this thing, because that's the tool you use to solve N+1 queries. But basically what I'm doing there is I'm telling Active Record to load all the recipes, and I'm hinting Active Record. So I'm giving it a hint and say, hey, by the way, I know that I'm going to need the ingredients, and I know that I'm going to need the vendors. Because that's kind of what you do when you're building regular traditional APIs with Rails. You just kind of know how you're going to use the data, so you just kind of send this hint to your object relational mapper. So if we look at them side by side, you see that I kind of color-coded them there. So like the recipes matches, like the recipe in green, ingredients match the ingredients in green, and vendor in orange kind of matches vendor again to the other side. And that's when it clicked. That's when I had like a realization. It's like, well, GraphQL, and especially GraphQL Ruby, gives you super easy access to the AST of the query that's coming in. So that's where I had that realization that it's like, yes, I can actually tap into the query and get some information about it for every query that comes in, because GraphQL has this amazing thing that just sends us all that metadata information about the sort of query that I'm trying to run. So that's when I realized, oh yeah, I can write some code that maps this query, and since it's just so similar to Rails, I can write code that just maps that, transforms the AST of like the query that's coming in, turns it into that hash, that ingredients vendor hash that Ruby understands, and I can just feed that into active record right away. And then I'll just basically I'll just try my best effort to eliminate those n+1 queries. So I hacked something together. It looks pretty horrible because it's a lot of meta code, but it kind of worked. And then we got results like this. So I could have 1 million recipes, I could have 1 million ingredients, or any number of those like permutations now, but I only do 3 queries at most. So there's like a lot of different strategies that you could use here. I could have written this as just, it turns everything into one SQL query for every GraphQL query that comes in, but that has its challenges too. So at some point, I realized that, yeah, I can actually do this level by level. So I analyze the query when it comes in, and I check level 0, I'm loading recipes, so I'm going to load the recipes. I check level 1, I'm loading ingredients, so I can just feed that into Active Record and tell it, hey, just load the ingredients for me. And the same thing for vendors, and it goes on and on. So if you're curious about this, check out this Ruby gem that I put together. It's under Neto Farah GraphQL Query Resolver. It basically we try like our best effort to just try and reduce that number of n+1 queries. But let me show you the numbers. So what did that mean for us at IFT? So I remember the day we flipped the switch. So we went from like the old APIs into GraphQL. So that was a very common problem at our code base. We had n+1s everywhere. And basically, almost every Rails API that you touch are going to be like that. So we saw a 60% reduction in database IOPS. That meant a ton of money that we could save. And also, one thing that I'm really proud of is that we completely eliminated memcache from our APIs. So we no longer take shortcuts with cache, and we just don't have to worry that much because we know our database queries are super optimized. Which leads to an extra thing that we can do that I'm really excited about too. That is selectively choosing the database environment to run my query in. So again, going back to all of that, because I can get that meta information about my query, I know at runtime if my query is read-only or if it has writes in it. So I wrote this like other piece of code that checks if the incoming query has a mutation in them. If there is, just use my regular write database. If it's read-only, send it to my replica database. And if you're sharding your database, you can just choose which shard to send this thing to. And it just becomes really, really cool because I can tell, well, it's all dynamic, but I can tell what that query is trying to do. And the result with this was we eliminated contention locking. So if you're not familiar with contention locks, it's when you're just doing a ton of writes to a few tables, and you're also trying to read at the same time. So as you write and read, you're just creating all of those locks in your database tables. So it becomes really hard to know, for the database to know how much time it should wait, and then you run into deadlocks, you run into these locks of like too much contention in the tables. Gone too, because now I can know with a certain level, if I trust that all of my queries in GraphQL are read-only, I know which database to send them to. So what are some lessons we learned here? Number one, the most important one, if you leave this room with only one lesson from my talk, I want it to be this one. Figure out batching as early as you can. So that's like number one thing. If you don't figure it out early, things are going to get really complicated. You saw like how much code I had to write in that like second example, and that's if you're using any of the traditional tools, you might have to do a lot of refactoring later. And you don't want to learn this in production. You don't want to learn this when it's too late. You want to use all the nice things that GraphQL provides, but you also want to be ready for like, running a super dynamic query language in your servers. Lesson number 2 is leverage the types. I couldn't think of like a better way to phrase this, but what I mean is like leverage all of that awesome information that you have at query time, all of those really interesting things, which kind of like connects to the challenge number 2. So our challenging number 2 was monitoring and errors. So that was the first thing I asked myself when we started to use it. It's just one endpoint. How am I going to use this with my traditional instrumentation tools? Basically, every instrumentation tool out there is just based on URLs, and it's based on patterns that you have in your URL. So if you're using something like New Relic, you get this nice little graph here, and it's like, well, that doesn't give me any information. That just shows me that I had like 4 other endpoints in my, and one of them was even like a health check. So like those are all the endpoints that I had, plus GraphQL. So wow, that just tells me that GraphQL is like 750% of all the time that I spend in my server. That doesn't help me with anything. That's like pretty much useless. And oh, that's gone. What's up with my errors? I had another slide with the errors. I don't know why it's gone. But yeah, all the errors get just rolled up with just, oh, there's an error in your GraphQL endpoint. There's 150 errors in your GraphQL endpoint. Oh, OK. So I know where to start now. So look for my errors. So we go back to lesson number 2, leverage GraphQL types again. So GraphQL Ruby has two really cool tools that are instrumenters, and they allow you to just enrich resolvers. And they have this concept of middlewares too. So you can tap into the query execution, see at which level of the query that you are, and just make some decisions there. So I wrote a little bit of code. And every time I receive a query, I set the transaction name based on the query name. And oh, yeah, that's another thing I would suggest. Always name your queries. It makes things a lot easier in the future. And then I enrich all of my resolvers. So I trace the execution speed. I create a new resolver that just wraps the old resolver and sends that to New Relic. And then I get my transaction table back. I know exactly everything that's going on in GraphQL now. And that first chart that I showed looks great again. I can see that, oh, GraphQL channels, GraphQL recipe recommendations, statements, and I can see what are like the most problematic queries that I was looking at. And here are my errors when they're not rolled up anymore. So I can tell exactly where those errors happen, which field that they broke, and things like that. So if you're curious about this, check out my gist. I would recommend, if you're not tied to New Relic or any other traditional monitoring tool, check out Apollo Optics. It's really cool. But again, it was like back in the day when we didn't have Apollo Optics, so we had to roll our own thing. So lesson number 2, proper monitoring is as important as good performance. You do not want to fly blind. If you want to do GraphQL in production, you need to be prepared for all of that. And lesson number 4, GraphQL is awesome. It opens up a lot of possibilities, and it just has spin up an entirely new ecosystem of apps, tools, and optimizations. I think all of these things that I showed here, it's just like it's barely scratching the surface. It's just like there's just so much more potential. And what I want everybody to think now is like just try and think of like all of this really cool new guarantees that GraphQL gives you, and think of all the sorts of tools that you can build going forward. And if you have any questions, you want to talk about anything GraphQL, just hit me up on Twitter or send me an email or grab me after this. Thank you.
Okay.